I want to be one of the first people to go on record by saying that I am a flat earther, and the reason that I'm the flat earther is not necessarily because I can prove every aspect of the flat earth as fitting perfectly into the model, because in fact I cannot. There are some things that I definitely have questions about. A lot of them are related to the maps, and we have been, discussing that for quite some time. What's really going on at the North Pole and South Pole, and even some of the questions that you and I have talked about, Jaron, about the things that we can see from the South Pole, or the things that, let's just say, the people in the Southern Hemisphere can see from the South Pole. So I brought up a couple of those things to Morgile, and I thought that we could just kind of talk about those a little bit. One of the first things, and you can elaborate a little bit more on this, Jaron, that we've talked about that kind of confuses me, and because I'm not even sure if it's true or not. But a lot of people have brought up the idea of the spiraling stars at the southern pole, supposedly going around Cygnus Octantis, which of course nobody can ever see. But also the fact that if somebody is in Argentina and somebody is in South Africa and maybe somebody is in Australia and they're all looking south, are they actually looking at the same stars? On a ball Earth, that would be very easy to explain and say, yes, they are. On a flat Earth, it represents some problems. And so that's kind of one of the problems that I'm having with it. And Morgile is actually going to try and do some stuff on Stellarium, and maybe kind of demonstrate this and show it out a little bit.
And so for me, it's insane that we have a lot of these problems, and people should be taking them and trying to prove them. For instance, the star issue. I don't think anybody even looks at the stars. And people might think in their head, no, I do. I go out and look every day. I would love to have something happen like where it came out that the stars don't even move at night. Like I bet you half the people wouldn't even have known. Like they haven't looked at the stars enough to really be surprised by that. Be like, oh, well, I was always told that they rotate counterclockwise and clockwise. And really, when you start to watch the sky and look at time lapse, which again, I wouldn't look at a lot of time lapse because those are done with concave cameras or what do you call it, GoPros, and they distort your view. Your view is not really what we think. It's not like the stars rotate like a ball. They almost kind of stretch across, or I don't know how to really explain it. It's like a huge wave of a movement, and it really gets confusing because if you're looking at a set of stars that are rotating one way, by just simply turning around, then they're rotating the other way if you're still looking up in the sky. So it gets confusing for people because I think we've all been taught that there's the equator. Anything above the equator, the stars move in a counterclockwise, and anything below the equator, they move clockwise. And it's simply not the actual truth. John, is that what you kind of come to?
Yeah, and another thing about the whole fisheye thing is I sort of relate you could call it a dome, or you could call it a electromagnetic field or plasma or whatever it is, but let's just say dome, okay? But that also sort of acts like a fisheye lens, and especially when you're in the south facing south, you're looking at sort of this downward slope of this dome or electromagnetic field, and so it distorts things. You're not seeing what you get. And so there is our ability to view things from the ground is certainly skewed, but then when you add these different layers of I guess you could say distorting fields, then it sort of adds a little bit of confusion to it. But we've got a couple things queued up, and I'm not sure the best way to do this. I've got a quick video that I wanted to run through and just maybe play a little bit of it, discuss it, play a little bit of it, discuss it. Or we could do this, I tried to do it with Stellarium, but my screen cap wouldn't work, or we could do this first. I mean, however y'all want to do it.
Okay, well, on mine, it finally finished downloading on mine job, and then John, and then I ran it, and then it was going into some application fault, so I'm sure that it's probably going to require a reboot, which I can't do.
Okay.
So
well,
I
this
don't know
will
if
work.
Jaron can do that.
Jaron, are you able to pull up the names of the constellations on this?
Yeah, if I highlight over them, it tells me which constellation we're looking for.
Well, I had a bunch listed. It was really nice in Stellarium, but I can give you the ones. So if we could, let's.
Where are we located? Where do you want to be on the map?
Well, we're going to do 3 places. These are all far south in the southern hemisphere.
Okay.
First, let's do Port Stephens, Australia,
Okay.
and anywhere in Australia towards the south is fine.
Okay. We'll be over here.
Okay. And then if you could, are you able to denote, well, there's the crux off to the top right. Do you see that cross?
Right.
There you go. So if you can click on that, there you go. Right, you passed it. To the right, right.
Yeah.
There, yep. So if you can click on that and mark it, is there any way to mark it?
No.
Okay, so just, well, there you go. The Southern Cross is a good one. So, and are you facing due south?
Yeah, I think I'm facing, yeah,
Yeah,
southwest.
face due south.
Okay. Okay.
Okay, so that's due south. Now notice that the Southern Cross is up and to the right, right? Okay, so that's one thing. Now go to Cape Town, South Africa, or southern tip of South Africa. Okay, and we're still facing due south. Now where's the Southern Cross? It is there. I think it's up and to the left on this one, if I'm not mistaken. Yeah, there you go. So the Southern Cross is way up and to the left. Okay, so there's an issue. Now go to Kalama, Chile, which is like the southern tip of. Oh, you were basically in, or maybe I'm looking at it wrong.
Whoops. Yeah, I'm right. I moved to here.
Okay, so you just moved there. Okay, so yeah, now look for the Southern Cross. Oh, well, that's where the one we're at. So now, go to Cape Town, South Africa then. Southern tip of South Africa. Did we do that?
Yeah, that one's the one that's in the upper
Way up
left
there.
here.
So the point I'm trying to make is here, okay, is if you're in the northern hemisphere, you're going to, if you look north, no matter where you are in the northern hemisphere, the North Pole Star is always due north, always. Okay, but when you're facing south in the southern hemisphere, the Southern Cross sort of, it goes around. And, the other thing I did too from these same three locations is I was just trying to see, what constellations can we see, and they're unique. So from Port Stephens, I saw Phoenix, Acamore, Valaris, Carina, Hydrus, Marissa. From Cape Town, South Africa, I saw Norma, Era, Pavis, Toscana, Aconner. From Kalama, Chile, I saw Vela, Garina, Meplakiao, Chameleon, Octeris, Pavo, Indus. So there's all these disparate, totally exclusive stars. These are all at the same time, which is totally contrary to what you see in the north. And no matter where you are in the globe in the north, if you're facing north, you're going to be able to see, basically all those same stars with the North Pole Star directly north.
Okay, well, John, let me just say what, in case you're missing something here. So if we're in the north, though, let's say we're where I am here in California, and we look at, so Polaris is up. Oops, I'm looking south. Sorry, let me turn around. Okay, so if we're looking north, so we've got the pole star here, correct?
Directly above the north.
Right,
Yep.
But looking at the crux is the equivalent of looking at this constellation here. So, because the crux is not the south star. So if we looked here and did the same thing, now we move to here, Europe, well, then that is going to do the same thing. It's going to be rotating around. Now it'll be up here to the right. You know what I'm saying? Like it's moving. The crux is not the constellation. The crux is not the southern pole.
Right, that's how you find the south, right? But
Yeah, and I think one of the problems is that people, and this is something Missa and I ran into, is if you look at these softwares, they've been built around a globe model. So you're not going to find so many issues with this to say that, because for instance, notice something. When I start going up like this, see the ground? So now here's a flat plane. This we all know we see. When I start looking up in the sky, look at the ground does. So why is the ground curving? Why am I getting a curved horizon? When I look up in the sky at night, my ground doesn't curve. So I've noticed some things in these planetarium softwares that are for a certain reason. When you start to play these stars going forward here, let me turn it to night so it looks better. When I start to play these stars and they are doing this kind of rotation, even this place, look here, where are we at now? So this is kind of, say, Japan or something over here. And when I'm playing these stars, we've been told if you look up north, they're going counterclockwise, right? But I mean, you'll see that around the horizon here, it's bent. It's like pushing those stars up that direction. Do you see what I mean? There's just something that I know is wrong with these softwares, because if you come down here and then press play, now you're going to get them to go, well, that kind of does the same thing, but see how they move towards the right, like down here? I don't know the constellation names, which I wish I did, but I don't.
Yeah, that's why I like Stellarium. I wish I could have done a screen share, but and you know the other big point is that you can't see Sigma Octantis, which is allegedly the South Pole star.
Correct.
So that makes it kind of hard to locate. But the point I was making, and you know you're probably right, but you would expect to see basically, you know, whether you're looking at them from a different direction or not. No matter where you are in the southern hemisphere, you should essentially see the same constellations at the same time, whether they're off to the left or off to the right, but facing south, of course. But you don't. You're looking at totally different constellations, and of course, if you turn around, you know, from north and start heading west, you're going to see them start to intersect with the other ones from the other side of the world. And if you go right facing south, then you're going to start to see the ones, you know, that were in Chile, but this isn't what we see in the north, so there's an issue here. And I'm just going to queue up a video and we'll just play little segments of it and talk about it, unless you guys had anything else you wanted to do on this. I found some anomalies, and this definitely needs further research. I had about an hour prior to the show to start doing this, and then of course my screen share didn't work. So
Morga, we are sharing you. I'm
okay.
presenting you, so if you want to share something.
Sure, and just real quick, this is something I touched on before, but this is sort of going against, because there's a lot of people saying, oh, well, you know, if you can fly from, let's see here, what was it, South America over to Australia in 13 hours, then it's a globe. But, you know, just going back to Zetetic, and I don't worship Robotham, but he had a lot of good points and he had his stuff together, but Cape of Good Hope, South Africa to Port Jackson is 8,000 miles. Port Jackson to Cape Horn is 8,000 miles, and Cape Horn to Cape of Good Hope is 6,000 miles. Now, this isn't theory. This is actually fact. This is taken from a Mercator chart, and he was also using the navigational logs of, you know, old school, you know, far south navigators. And so my whole thing is if it's, let's see, 8,000, 8,000, 6,000, if it's 8,000 miles from here to here, and these are an average longitude of 45 degrees, or a mean longitude of 45 degrees, these 3 points, then first of all, then that distance, 22,000 miles around thereabouts, is wider around than the equator. So first of all, not only does that debunk the globe Earth, but it also shows that flying from south of South America over to Australia, well, going this way and coming out over here, is totally doable. Okay, so starting in south of Africa, Cape of Good Hope, from there over to Australia is Port Jackson is 8,000 miles. From Australia, Port Jackson over to Cape Horn in South America is 8,000 miles, and from Cape Horn to the Cape of Good Hope is 6,000 miles. Now there's a mean longitude here of about 45 degrees. And when you figure up all the calculations, this right here is actually wider around than the equator. And now we're not talking about in theory, we're not talking about, you know, based on longitude calculations. We're talking about actual Mercator charts, and we're talking about actual South Sea voyages. And so my whole thing, first of all, is not only does this disprove the globe, because the 45-degree south latitude couldn't possibly be wider around than the equator. So that's one thing. But the other thing is if it's 8,000 miles from here to here, that's totally doable. And especially if you're talking about New Zealand, which is a little bit closer, which is like right here, that's totally doable in 12 to 16 hours, maybe even shorter than that if the plane's going a little bit faster than average. So, you know, the whole thing where people are saying, you know, because Mark Sargent said that you can't fly from here to here in 13 hours, then, you know, that's proof of a flat Earth. But the thing is, this is going back to the original Zetetic. And again, these are actual distances that were measured and not calculated, but actually measured and voyaged. That flight, being less than 8,000 miles to here, is totally doable in 12 hours in a conventional airline. So, you know, anyone saying that this debunks the flat Earth is totally misguided, and they should probably go read Zetetic for one. And also, just so you guys could have a visual representation, these are sort of the three areas that we were looking south from in that original stellarium demonstration that we just did. So with that being said, just to sort of give you guys a little background, I've got a video queued up here, and this is something that was actually posted by Eric Dubay, and most of it's ripped from other people, so there is not a copyright issue. Eric, many moons ago, gave me permission to use his stuff, and it's not an issue. So I'll just play a little bit of this, and then we'll stop it and discuss, because it goes through it pretty quickly. Okay. So first points first, stars are turning around that dome. Now, whether it's a glass dome or whether it's an electromagnetic field that sort of warps and curves light waves as it passes through, we'll call it a dome just for argument's sake to make it simpler. But it says all stars rotate east to west around the Polaris just above the central North Pole, like in a planetarium dome, and that's agreed. Everyone agrees with that. So we'll play it a little bit more. Okay, so perspective, and this really does come into play. The amount of sky we can see depends on where we are and which way we're looking. The dome, or electromagnetic field, the sky we can see, and here's this little lines right here is the apparent horizon for the observer, and this right here is the apparent horizon for the stars. So since the stars are on a far removed plane and it's very vast, we're limited to what we can see on the ground because of the ground, but we're not limited to what we can see in the sky because of the ground up until this point here, where anything below this point is invisible. So perspective works on the ground differently than it does in the sky because it's on a far removed plane. Our Earth planetarium, however, is so vast that perspective doesn't allow you to see all the stars from any one vantage point, which is agreed. So we'll keep on going, unless you guys had any questions or comments on that so far.
No, I'm following you so far.
Okay. Okay. Sky seen from the North Pole. Not to scale, by the way. All these are not to scale. You can, however, see Polaris, Ursa Major, Ursa Minor, and other northern constellations from every point on Earth all the way to the southern Tropic of Capricorn. So I guess that would be probably somewhere around here, around this area. You can see all the northern stars from those vantage points. So that's an important thing to sort of keep in mind. Okay. The supposed South Pole star, Sigma Octantis, the southern crux, and the other outer constellations, conversely, cannot be seen simultaneously from every point in the southern hemisphere, the way Polaris can from every point in the north. Now, this is sort of what we were showing you guys in the beginning, is, and this is a very good point. The south, there isn't this bilateral symmetry that you would have to have on a globe. The southern region is much, much different than the northern region in this very, one regard, that you just simply can't see all these same constellations simultaneously from, disparate locations in the southern hemisphere. So that's just sort of, another way to describe what we demonstrated earlier. Okay, nor do the southern constellations circle around it west to east as claimed by modern astronomy. No matter where you are on Earth, all stars rise more or less in the east and set in the west, with the angle or inclination being based on where exactly you are on the Earth and what direction you're facing. So does that make sense to you guys, or should we try to break that down a little bit? Or
I think that's important, and it's something that I know, but I don't know if people understand that just like the sun and the moon, the stars rise in the east and set in the west, and based on your view of the, let's call it a dome for what lack of knowing what it is, but if you were to picture yourself being at different places on a flat plane looking up at a curved dome, based on your view, it may give the appearance that as the stars rise east, set west, that they are turning on a curved dome, but it doesn't mean that they are.
That's absolutely right. That's absolutely right. And see, that's sort of what I was saying towards the beginning. We see light and we think it travels just in straight lines, but it actually doesn't, especially if it's passing through a dome or an electromagnetic field that is dome-shaped. And so, yeah, that's absolutely right. It sort of causes an illusion that instead of even if it's going in a straight line, it may appear to go up around in a curve and then back down the curve. So, that is an important point, and unless anyone else had questions or comments, but that's a good way to put it that you said, Jaron. Continue.
Yeah, so what is it then that we're seeing, guys, when we see the footage of shots, being shot around Sigma Octantis, that appear to be going full circle around maybe that point, but around something, it appears that the stars are actually going full circle on the south. How is it exactly that that's happening?
This actually sort of goes into a little bit more detail on that.
Okay.
So
And
we'll
I
just
am aware of that. I just thought that you might want to know that that's coming up because that was the big question in my mind. And I sort of understand it, but having you guys explain it a little bit may put it a little bit better for some of the viewers.
well, if you can see my cursor, I don't know how big that is, but
Yeah, we can see it.
okay, let's just say that a star is actually going perfectly straight this way, right? But if it's passing through sort of a curved atmosphere or a curved dome, instead of going straight, you're going to see it go like this, and it's going to appear to go around. Okay, so that's one
Right.
thing. All right, so let's just continue. Okay. Modern astronomy claims the stars rotate one way in the northern hemisphere and the opposite way in the south, but this is a drastic oversimplification used to bolster their ball model. Agreed. This is another important point because a lot of Globers sort of use this as proof of the globe. And I know Jaron's made a video on it. I made a video response to Zach at New Tutora on this because it's so ridiculous. And I'll just try to read this too, and then I'll make a comment on it. I wish that would disappear, but let's see. Blah, 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 blah. Something. The moon viewed from the northern hemisphere is seen right side up, but when viewed from the southern hemisphere appears upside down. So here's one from the northern hemisphere, and here's one from the southern hemisphere. Therefore, we live on a globe, right? Now, so that's an important point that is actually totally possible in the flat Earth model, just because you're looking up at the moon from different angles. The way I would put it is, tape a quarter to your ceiling and look at it and say the head is up facing you, the head's facing you, and the neck's away from you. If you walk to the other side of your room and look up at that same quarter, now the neck is facing you and the head's away from you. Does that mean your room is a globe? Or does it just mean you're looking at the quarter from a different perspective, right?
Exactly. Yes.
Okay. Yep.
And
Right.
that's easy to wrap your head around.
Right. And if we add to that now picture you're in a domed bedroom and picture stars and them turning, and then you walk to each side of the room, it's going to give you completely different views of what the stars are actually doing.
Right.
Totally right.
Yes, that's correct. I see that. Okay. Okay. Would they cut the sound out of this, John? Oh, there it is. Okay. Not that it was important or anything.
Okay. I think I had my mic muted. Could you guys hear the sound okay, or was it really low?
We could hear it when you, I guess, unmuted your mic. And I have
Okay.
the same problem with mine. If I mute on the screen, if I mute the mic from the Google control, it mutes out everything.
I just have a little mute button on my mic, but okay. So as you
Okay.
travel southwards from the North Pole, Polaris and its surrounding stars decline in the sky due to perspective, which is pretty easy to understand. You know, the further you walk away from, say, let's say you're standing and looking at a uh, church spire, and if you walk away from it, say 100 feet, that church spire is gonna appear lower towards the ground. And if you walk 1,000 feet, then it's gonna appear right next to the horizon. And then if you walk another 500 feet, then it's gonna be invisible. That's just how perspective works. If something's above you, the further away you get, the further and further down it's gonna appear to get. So that's a good explanation. Due to perspective. So at the North Pole, Polaris is situated directly 90 degrees above your head, but in the mid-northern latitudes, like here, it's about 45 degrees. So totally makes sense. I guess that's Polaris right there, and it's about 45 degrees above the horizon. So that's your, I guess, azimuth, if I'm saying that right. So we'll just continue unless you guys had a comment, question on that.
Nope, and that is correct. That would be the azimuth.
Yep.
Or the elevate. Yeah, up at the elevation, left, right is the azimuth.
Ah, well, there you go. Shows what I know.
Yep.
Close enough. Close enough. Close enough for Globebusters.
That's right.
Polaris remains fixed while all the other stars rotate 24-hour circles around it. The stars near Polaris rotate very slowly while those further and further away rotate progressively faster. So makes a lot of sense. We'll get to the diagrams and sort of the explanation that sort of made a lot of sense to me. Okay, and I think we already covered this diagram, so he's just repeating that. But well, no, this is a little bit different. But yeah, it's an important thing to point out, and I did something like this as well in one of my videos. So, you know, if you're standing here, your horizon is going to be here. You can't see anything, you know, beyond that point on the ground. Now, a star that's directly over your head is going to be directly over your head, but a star that's way over here is going to drop to about here, and then a star that's way over here is going to be down here below this, below your apparent horizon. So again, it's just sort of showing that the laws of perspective still apply to the stars, but they apply differently, and so it's very easy for us to confuse, you know, our apparent horizon on the ground with the apparent horizon of the stars, because these stars are way more distant than this, but this star up here is going to appear right next to the ground. So that's sort of how that works and what they're showing here. Okay, so here's another one. The dome, the electromagnetic toroidal field. Because the sky is so far above you, you can see much more sky than land. So here's your sky horizon. Again, it's going to appear right here next to the horizon, even though it's way over here and up there. So here's his field of view standing here. And then beyond the field of view is anything that is below that point. With us so far?
I'm with you so far.
Okay, so this is a little bit more confusing, but here's a guy at the North Pole. He's down here, right at the North Pole. His field of view, again, it's the same thing. Your field of view on the ground is only based on how high you are up, you know, 6 feet, 7 feet, whatever. And Jaron, I know you know the equation, but for a 6-foot person, the apparent horizon is about 3 miles. But in the sky, the apparent horizon might be 5,000 miles, but it's going to appear that it's 3 miles away close to the ground, if that makes sense.
Yes, that does make sense, and I have seen that before.
Okay, so this is how it looks from the ground. Star trails form circles near the center, so that would be here, and this is what you see if you do a time lapse or a long exposure. And as you get further and further away from that point, the circles get bigger and look like straight lines when viewed from a narrow field of view. So that's a good way to put it, because if you're, say, near the equator, or even if you're towards the north looking south towards the equator, the stars don't do such a perfectly circular pattern, but appear to be, essentially straight lines, okay, or maybe slightly curved lines. So here's what you'd see if you were looking at point 2. You'd sort of see the, the middle edge of these stars going much more fastly than the stars close to Polaris. And 3, this is the very far south stars. Stars go along the horizon near the edge, forming lines. So that's really, when you get way down here, they're essentially doing what you would observe as straight lines, because you're never going to see all that curve. Your field of view won't allow for it. So, make sense?
Okay, well, it does mostly, but I'm still, I still keep thinking about those videos where they
What
are going in perfect circles.
I see what Bob's saying, and Bob, let's picture. Leave this slide up, John.
Sure.
Let's picture that we're standing at the number 3 there, okay? And
Okay.
if you're watching the stars in the sky, since you can't see, all the way up, say where 1 is, so that we're kind of pretending this is the flat Earth, I guess, then? Correct? This circle?
That's right, yep.
Okay, so if we're standing at 3, and let's call that Australia then, and we can't see 1, right? So
Right.
if we kind of look at that picture again, or think of that picture that John showed that showed the inclined view that showed the stars, if you kind of picture that, where those stars are curving, but in your perspective, they are doing a circle, even though it's going around the bottom. I don't know how to explain it. So they're going around the base of the circle. They're going around where those, if you look at the number 1 there, and you look at the next line down, and then down below that there's like 3 lines over there. Well,
Okay.
to your perspective from 3, maybe those stars would look like a circle in the sky. You see what I'm saying? And I understand your problem, because this is the problem I have too, that there's some sort of perspective issue that is causing those stars that are going across your horizon to bend to your perspective.
Right.
Exactly. And that's why we're seeing that full circle. I could see it, it would make a lot more sense to me if I was just seeing like a slight arc, or even a fairly substantial arc, but the thing that really screws with me is seeing the full circle star pattern.
Well, one of the things to
That's the
look at.
part I have a hard time reconciling.
So explain this though. If in a full circle star pattern, that means that it's a full day has happened. So how do we have 24 hours worth of stars, which is impossible? Where's
Yeah.
the
Well,
sun?
that's a very valid point. You're right. So obviously then those time lapses clearly can't be showing a full rotation of the stars. The rest of it must be then extrapolated.
Yeah, I see, and this is what I don't really know either, because I would think that they would have to be 2 days worth of footage, or 3 days tied together, but even that wouldn't give you a full circle. It should just be a bunch of half circles.
Yeah, that doesn't make a lot of sense, because you're absolutely right. It would require a full 24 hours to get a full star orbital, and that simply can't happen, not even from the North Pole, because,
Yeah, now
well,
I'm
maybe
like
it could in
like
yeah.
scratching my head over here, like, what the hell?
I know. See, and this is one of the issues that I have with it also. But now in the North Pole you could do that, because they have, when it gets into the dead of winter, you have those long nights where you could actually see that happening. So I can see that there. But on the
I
South
think
Pole, I don't think anything is far enough south latitude to be able to pull that off.
no, because you shouldn't. Even I've had somebody email me from the southernmost point of New Zealand, and talking about interesting also. She said that she's got her house situated, and I know how this feels because it was our issue in our other Salinas house. Is you can kind of learn where the sun is based on how the light comes into your house. So this lady said that her room is situated that only 2 or 3 days a year does the sun come into her bedroom. because her bedroom's on the south side of the house, and the sun gets as far south at the solstice that it peaks. The sun can come through her window, and she said it's like 3 days, and then it starts going back north. So her question to me, or her point was, I don't think there's any such thing as the 24-hour sun in Antarctica. She said, because when that hits my window for those 2 or 3 days every year, it then starts going back north. So she said, so I know the southernmost path of the sun. So she said, how can Antarctica be getting 24-hour sun if I don't get 24-hour sun and I see the sun go as far south as it goes? Because then it starts going back towards the equator and up north. So I mean, that's a great point, is that she's kind of proving it, that the sun would need to go further south in order for Antarctica to have longer days, but it doesn't do that. So it's kind of the same issue. And another thing, and this is kind of something I wish people would do and get out and do, we need to do it more, because remember, Bob, when I told you the night after we did the test at the beach and Miss and I were sitting in 2 different locations 8 miles apart, and we were
Right.
watching planes, and in calling out where she would see a plane by what star or in what direction, they were, obviously completely different. If she saw a plane above her head at 40 degrees, and then I would look and it would be way off to my left at 30 degrees, and we just kind of realized the difference that perception makes, perspective from the ground at looking at the sky. But then when we saw the ISS, we saw it both go through the exact same star, the second star of the Big Dipper. So what that proves to me right there is that the stars must be the same height as the ISS. Whether or not, that doesn't mean, again, for all the people who say, oh, the ISS, I can see it from the ground. I'm talking about the dot, the light, not necessarily the
Right.
contraption, but the light that they say is the ISS crossed the exact
U2.
same star at the exact same moment in both of our fields of view. So what that kind of leads me is, if we were standing at, say, number 2 on the ground, and both of us were looking up at the number 1, well, if you picture a plane that's not quite so high, to my perspective, and somebody who's not next to 2 but is a little bit more over somewhere, we're both going to see that cross different stars in the sky. But then if you look at the actual number 1 and you picture somebody, yeah, right there, if you picture there's a star attached to that dome and also a light going across that dome, for us both to see it cross that number 1 would mean it's equally in height. So it's kind of the same issue, that I think there's so many more tests we can do, and photography, even with 2 people in the same city, that they're 10 miles away from you, have them record the sky and have somebody else 10 miles away record the sky at the same time. If you get an hour footage from 2 locations 10 miles apart, you're going to see exactly what's going on based on planes going by and then comparing the footage. There's just so much that we can do.
All right, and
Okay,
there, yep, we're
this is
live with your screen.
okay. So yeah, I thought this was a pretty interesting photo, and I wish they would have put longitude and latitude, like where exactly are we at. But I believe this is in sort of the south. And how is this possible? You got a circle here, and I guess that would be facing due south, and then you've got these lines. Now, does this happen in the northern hemisphere when you're looking up at Polaris?
Not that
No.
I am aware of. No, it does
No,
not.
it doesn't. So what this is showing me is that there is some sort of, I guess occlusion is not the right word, but maybe like some distortion in terms of the light that's passing through this, for the lack of a better word, dome. But I totally agree that it has to do with scale, perspective, and horizon. And we're sort of poor observers here on the ground for a couple reasons. Again, here's your horizon. Now, does that mean that this star right here is right next to the horizon? No, this star right here is way up in the sky, but due to perspective and its distance from you, it appears that way. And so, we're seeing all sorts of anomalies in the south that you just don't see
Right.
in the north.
Let me ask you something though, John. I think that this particular shot may have been a shot used as an example from the equator. And if I remember right, Jaron, didn't you do a video that was showing basically the divergence of the stars going in each direction off of the equator? So is that not what we're looking at here then? Because I can't reconcile this in the south.
Yeah, that's what that is. It looks like it's from the equator. It's the video where I did the minute physics debunking. Um,
Right. But so where is this circle coming? Here's another circle. Here's a circle, but in the north you don't see this. Now, if this is the
That's true.
equator, if this is the equator right here, um,
it
to
has to be
me,
moved. The camera has to have been moved, right?
it looks like a long exposure to me with
But I mean,
everything.
it
Well,
has to.
again, we've got that full circle indicating 24 hours, which we know can't be done unless it's in the north in the wintertime.
I don't think it's a full circle. Like, see, this one here is just a short line, so that's maybe a couple of hours. And the
Well, it
sun's
could be.
rising. Is that the sunrise there, or is that city lights? 'Cause I was going to say that can't be east, can it?
Uh, yeah, that doesn't make any sense because
It
no, that can't be east.
it would have been nice if they would have put like which direction we're looking and where we're at. But I just thought this image was interesting because it sort of demonstrates the point that I was making that the starlight that we see is having to pass through this bubble of sorts, and so it really does distort the way that we see things. And you just don't see this sort of pattern. I don't care how far you are close to the equator. If you're facing north, say that's south, if you're doing the other thing in the north, you just don't see this. So it's very telling that there isn't this bilateral symmetry in the two hemispheres that you would necessarily see on a globe. So this is a real good sort of I know it is sort of confusing, but I think this is a good demonstration of what I'm talking about here. Um, anyway, continue.
Okay.
So
Okay, I've
they're
got it.
sort of going back through some of the same ones, but there was some other stuff here, and a guy he was actually able to get stellarium to screen cap. We've seen these slides before, viewed from the equator. That's an important point to make. On the horizon, on the dome, the closer we are to the edge, the lower our sky horizon is from each side. So viewed from the equator, your sky horizon would be lower on each side the closer you are to this edge here. So that's sort of what they're saying, and that's where I believe we're getting these sort of anomalies in terms of stars appearing to rotate, but they're not actually rotating, they're just passing essentially in a straight line, but it's that warping of that dome or electromagnetic field that sort of causes an optical illusion along with the laws of perspective that sort of makes it appear that way.
Yeah. And actually, Vsauce did a really good video on perspective and images that tend to compress, and possibly even explaining like the moon phases and stuff like that. And I'll put that up in the link that I thought was really interesting for people to check out as well. Okay, so view from the equator. Moving forward on this one.
So apply star trails. I'm not sure what they're trying to show here. But if you sort of look at that previous diagram, how your line of sight is going to be different at like let's say this is the equator here. Maybe I should just slide it back a hair so I can get a merging of those two images. Maybe a hair more. There. Um, so here you are at the equator. You're looking at a lower edge of the electromagnetic dome from this way. You're looking further off into space this way and way further off into space that way. So it's sort of like, it's not, even if all the stars are on the same plane, the light's going to sort of bend into this matrix here, if you will, and it sort of causes some optical illusions. That's the way I understand it.
Yep, that's absolutely true. So in any event, I think these are this is some good example, but this is like a little bit difficult to explain, I think, for the average person. And but yet, I understand, in principle, I guess what Eric is trying to say in this video, and also what you're trying to say. And I think one of the things that helped me the most tonight is realizing that obviously these 24-hour rotations that a lot of the time lapses we're seeing, it can't be 24 hours, and that never even occurred to me initially, because of the fact that on a lot of them we're seeing complete 360-degree rotations. Um, but yeah, so I mean, there's obviously still some, I guess, not erroneous data, but misleading data. I think that kind of makes this a little bit confusing for people. And when you run across stuff like this, it raises questions in your mind, and people are right to question this kind of stuff. It's like, why does it appear to be doing this? Why is it that we see this, and what is it exactly that we're being presented with? And I think kind of taking apart the evidence and understanding the evidence rather than just believing what the presenter is trying to say, but understanding what's actually going on with the presented evidence helps a lot. And I think that that's where a lot of people just don't go, and they kind of rely on the real researchers like Dern and Morgile and all the other great researchers out there that are doing this to come out and explain it. And
This one
there's a
here,
lot to it.
this one here is sort of the one that sort of helped me wrap my brain around it. And it is confusing, I agree, but this is one of those things that we sort of have to address because, for me it's good enough to say I know for sure the Earth isn't a globe, and so there's a rational explanation for everything, and this makes a lot of sense. And if you can sort of, and I guess we should probably link this video up. And there is about a 5-minute section where a guy's using stellarium to sort of demonstrate his ideas on it. So maybe if we could have 5 minutes to do that. But just this little diagram here sort of sums it all up. If you can sort of imagine that this is the flat Earth, and the way that these yellow lines apply to these yellow lines, it makes a lot of sense why we're seeing these two spiral patterns. And it's not because we're looking at different opposite sides of the globe. It just has to do with how light behaves when it's passing through these different layers. And it's a very good explanation for me. And what I'll probably do at some point is do a video sort of expanding on this, and maybe try to figure out a way to demonstrate it a little bit more easily so that people can understand it a little bit better, because it is confusing. But this slide right here is a real good sort of example of how this works. So I thought this was important, especially since we were talking about this topic tonight. I wished I'd have known it earlier. I'd have put something together a little bit more professional. But if we could just roll this 5-minute clip, and I'm not sure I necessarily agree with this guy that Eric sort of used his clip, but since I can't use stellarium, if it's okay with you guys, I'll just roll maybe 5 minutes of this.
Sure,
All
that
right.
works for me.
It's a little noisy.
Okay, so we look up at the sky and face north. And,
Yeah, you might want to kick the volume up a little if you can, John.
rotating anti-clockwise around.
No, up, not down.
Oh.
Now, if we face south, then in the planisphere projection, which is very much like what you would actually see, as opposed to some of the other projections that you can commonly see, which don't reflect what you would actually see very closely. But in this projection, when we look south and we stand in the UK, we see the stuff sort of drifting across the sky. It's not a rotation in the Earth or whatever. It's a sort of flow of stars here from left to right. Okay, so what happens in this projection if I visit?
I'm not sure how much of that is actually going to be coming out on air, John. It's pretty faint.
So you want to kill it?
Yeah, or maybe feed me the link. I might be able to get a little bit more level out of it, but it's just really, really down in the mud.
It's real noisy. He probably should have used a noise gate, but okay, so we can skip it. But anybody that's interested, Bob, I'll send you over the link to it. But it's just simply, I mean, you can search it. It's Flat Earth Star Trails Explained. It is from Eric Dubay. He puts out some good stuff, and I'm not sure who the guy was that originally posted this, but I'd like to talk to him because he has a pretty good understanding of it. And my position on this is, whoa, whoops, was that me? Sorry.
That was me actually. I've got the video up on this side, and it seems like there's more audio to it here.
Okay, you wanna do it then?
Yeah, let me back up just a little bit, and then if it's weak, you guys let me know. So
Okay.
where are we starting at, about 5.5 minutes on it, or?
About 5:15, something like that.
All right, fair enough. Let me stop sharing on you and go back to me. And there we go. Okay, so there's that. Now
And the planisphere projection, which is very much like what you would actually see, as opposed to some of the other projections that you can commonly see, which don't reflect what you would actually see very closely. But in this projection, when we look south and we stand in the UK, we see the stuff sort of drifting across the sky. It's not a rotation in field of view we're looking here really here. It's a sort of flow of stars here from left to right. Okay, so what happens in this projection if I visit Australia or New Zealand? So we could.
Check, check. We still on?
Sorry. Yeah, we're still on. I'm sorry. I had my other mic muted. So I stopped that because I think it's just we're losing it in the mud. So I'll
Okay.
put it in the show links.
Yeah.
And we'll just go that way. So let me go to, oh boy, something else here. If I can get my
Why is the
screen
ground
to...
so curved here?
Yeah, that's how stellarium works.
Well,
It's kind of
see, that's the
weird.
thing we have to look at. There's a reason why they have to show it like that. It's because otherwise it doesn't work on a ball. They have to curve the ground in order for the stars to curve like they want them to, and that's why I mean that what I think we would see in reality is.
I'm now going to.
Whoops. Sorry, guys. I am having some problems getting my screen to stop. There we go.
And it's kind of difficult to learn. The learning curve's a little bit much, but okay, let me walk you through some things, Bob. Go down to the options below. Okay, and then check for me show never rise region in the little check boxes.
All right.
Show never rise and set region.
Show
the one below it.
rise and set. Okay. All right.
Show the circumpolar region and
Okay.
show the angle. Okay. And then over on the left, put that little marker in where I live, so somewhere in California. Okay. So this is great because you can set it all up. Now, on the right there, Bob, where it says add stars randomly. Yeah.
Okay.
Yeah, click it once and then click it again. Okay, so on the left-hand view, you see how there's a star up there at the top on the
Okay.
left side view?
Yes.
Can you go grab it? You can just take your mouse and grab that star and drag it all the way down and put it right outside of that blue circle at the bottom.
Just anywhere?
A little lower. Keep going lower. Lower, lower, lower. Yeah, maybe
that
there.
blue circle. Okay. All right.
Yeah, so right there. And then, is there another star? Did you click it twice? I don't see the other star. You can rotate the globe on the left. Just
Yeah,
grab it.
it's right on the front green part. Oh, that's on the right side. Sorry.
There it is. Down there. And then take that one and make it the North Star. So drag it up and put it right by the North Pole.
All right, right there.
No, all the way up at the blue pole.
Oh, all the way at the top. Okay.
Yeah. Okay, and then over on the right, you can grab and manipulate that round ball. So kind of make the plane flat for us. So kind of go, yeah, there you go. Okay, so there. Now, from where I'm at, now if you go down where it says Start Animation.
Okay.
On the, yeah, right there. And it's going to start playing like a day would, and it shows everything rotating for you. And what I've noticed is, so where I'm at in California, should I be able to see stars that are as far north as the North Star that we put up there? And you'll see that when this star comes up and around, I can see it too. So you're talking about a star, I can see basically 320 degrees of the night sky from one point. See how that star comes up above my horizon?
Right.
Right, and it's showing that like the blue region is the never rise position, meaning any star there will never rise above my horizon. See what that means? And then the red
Okay.
is the red is the what is the red again? The always rise or something? Yeah, always up. The always up star position. And you can change this and play with it and manipulate it, but there's a lot of things in here that tell me that it's not as simple as a ball that is, from the equator you can see, so basically from the equator, does somebody at the equator see all stars?
Yeah, I see what you're saying.
Right, and that's why I just have a problem with it because it doesn't. I know, and this most people will get here, and believe me, Bob knows that I've gone through the trials and tribulations of getting somewhere and thinking, oh shit, this proves the ball, but nothing would prove the ball except for there would have to be a preponderance of evidence. But something like this, when you start to play with this, you may think at first, well, this so accurately describes. Then you need to remember that this is a computer program set to work as if the Earth was a ball. Right? But
Right.
it also has to pretty much maintain its truth as far as coming close to reality, because otherwise somebody would just call it out as this thing's completely bogus. So from there, you can start to draw connections and realize things that happen here that don't happen in real life, things that we've filmed with stars, and then also you have to really remember the sun and how the sun rises and sets in each location. See, now you can take that in the lower left, Bob, if you grab that dot again on the map,
Okay.
and if you drag it left, it will go and it'll come out the right. So keep dragging left, and you'll notice it pops out on the right. Now, if you
Okay.
drag up, you would, this is what That's what I was trying to say in my last video. Where if you drag up, shouldn't it come out the bottom? But of course it doesn't. It will stop.
It doesn't.
Right,
Right.
because the map doesn't work that way. But this is what tells us. It's funny because people say, well, this map makes sense. Like for instance, for Tiger Dan to come out and say the flat Earth map doesn't work would be the same thing as me showing this map and saying this map doesn't work. I'm done. I'm not a globe Earth believer anymore. It's like no, it's not this. It's a representation. It's not a real map of the Earth. But this is how we think of the planets or the continents look. We think they look like that. But of course, Greenland is 1/14th the size of Africa. Yet in this picture, they look 1/3 or a half even.
Right. Oh, this is a neat little animation. Where'd you find this? You and
I'm always just looking around for stuff. Yeah, but you can add. You can add star trails. I didn't see we didn't have that checked. If you go down and hit long star trails or short star trails, it'll start drawing them. But this is kind of what I was saying earlier when I said from the south, it will appear that you're drawing circles in the sky, but really it's not. But that's why I'm still wondering. And for me, the biggest thing is still that whether or not the southern star is actually moving. Because I'll be the first one to admit that there is a significant problem with the current flat Earth knowledge if the southern star does stay in the same position in the sky throughout the entire night.
Right, but you can't see it though.
No, but I'm saying that location. But it doesn't, even if it is a significant problem, there's many reasons that I would be able to research from there and see what could be happening. The problem is I don't want to research anything until I know that's what happens. In the north, I can go outside and watch stars and see what they're doing and look at their inclination and measure their degrees at certain times of night. But I can't do anything in the south. So when I watch time-lapse, there's very few time-lapse footages from the south. On top of that, you can't even get really below the 60-degree marker, right? Which is kind of crazy because you would think, and then you have to think, well, there's a reason why they don't let us go down there. Then you have to wonder, why did they fake all that webcam footage I showed from Antarctica? Why are they saying there's a 24-hour sun, but then cutting the film for 5 or 6 hours a day? It's because it gets dark. And if they showed us that, we would know it's all fake. So everywhere you look, you're going to find pieces of information that's left out. If somebody is just taking a glance or a look, they're just taking a little overview, then it appears everything they've ever told us jives. Well, this all makes sense. There's the 24-hour sun. This happens there. They have it also in Norway. Here's this little star chart. Looks like it makes sense. Boom, Earth's a ball. That's how most people will take it. But if you just realize that the way they taught us the ball, the way they taught us this, the way they lie about these things, the way they just don't want you looking into it, or else, heaven forbid, you'll be called an idiot. Oh, you'll never believe it.